All right, so second page of the midterm. Why is angle 4 congruent to angle 5? Oh my goodness. Let's try this here. Okay, so angle 4 congruent to angle 5. Well, are they inside or outside? They're inside, so that's interior. Are they on the same side or alternate sides? They're on alternate sides, so it's alternate interior angles. There you go, there's your answer. 18. Why is angle 4 congruent to angle 1? Angle 4 and angle 1. Well, it looks like they form an X. And when we have the X, we call it a VA, or vertical angles. Why is angle 2 congruent to angle 7? 2 and 7, are they inside or outside? They're outside. So that makes them exterior. Are they on the same side or alternate sides? They're on opposite sides of the transversal, which makes them alternate exterior angles. A new fence was built by showing in the diagram. Okay, so we got a new fence here. The new fence is the black lines, and the old fence is the dotted lines. All right, about how long was the old fence? All right, so we've got 90 degrees, which means I can use the Pythagorean theorem, which gives me 35 squared plus 45 squared is equal to c squared. Oh my goodness. 35 times 35, that's going to give me 5, carry the 2, gets me a 17, 5, carry the 1, gets me a 10, gets me 1,100 and, nope, 5, 2, 1,225. Check my math on that, I might be wrong. 45 times 45 gives me a 5, carry the 2, gets me a 22, 4 times 5 is 20, carry the 2, gets me an 18, this is going to be 5, 2, 0, 2. So it's going to be 1225 plus 2225. Add those together, I get a 0. Carry the 1 gets me a 5. No carrying this time, so I get a 4. And 3,450 equals c squared. I square root both sides. Looking for the square root of 3,450. Goodness gracious. So 40 times 40 is 1,600. 50 times 50 is 2,500. 60 times 60 should be 3,600. So it's a little bit less than 60 times 60. So let's try 59 times 59. Well, let's do 58. That'll be easier. 58 times 58. So I do 8 times 8 gets me... Jeez. You know what? I'm going to go ahead and erase this. We'll come over here and we'll do 58 times 58. 8 times 8 is 64. Carry the 6. Gets me a 6. A 4. 46. Okay, so this is going to be 40. Carry the 4. Gets me a 29. We have 4, 6, 3, 2. That can't be right. I must have done something wrong there. Let's try a calculator real fast, just to make sure I know I'm not losing my mind. 58 times 58. Yeah, I did something wrong. Okay, so did something wrong. Go back, check it out. Let's say 58 times 58. Let's try that. Not 55. 58. So 8 times 8 is 64. Carry the 6. This should be 46. 5 times 8 is 40. 5 times 5 is 25. Plus the 4 makes it a 29. Okay, so 4, 6, 3, carry the 1, there we go, 3,336. That's pretty close. These two numbers are really close. So it's somewhere between 58 and 59. So when it says approximate, I'm going to say it's about 58 meters. There you go. There's number 20. 21. Which transformation, let's go ahead and erase this. Okay. Which transformation occurs from figure A to figure B? Well, this one's going to be tricky because the eyes are looking different directions. See that? The eyes are looking to the right over here, and now they're looking to the left. So that tells me that it was reflected across the y. Everything over here is now switched. So I say reflect y-axis. Okay. So for number 22, what conclusion can you make about the triangles 1, 2, and 3? What? Oh, they're going to tell us what the triangle right here. Okay, that's my bad. Sorry. If the sum of the squares of the two smaller sides of the triangles is greater than the square of the longest side, then the triangle is acute. Okay, so this is setting up the property. Okay. So now the triangle 1 has side lengths 8, 10, and 12. Okay. Doesn't really tell me very much. Triangle 2 has 8, 10, 13. Triangle 3 has 6, 8, and 10. 6, 8, and 10, I can reduce these down to be 3, 4, 5, which gives me a Pythagorean triple. So I know that triangle 3, I'm going to put this right over here, triangle 3 is a right triangle because of the Pythagorean triples. So now if I say, it says the square of the two smaller sides, I say 8 squared plus 10 squared is something to 12 squared. This is going to be 64, this is going to be 100, this is going to be 144. So I say that this is not that direction, this direction. 164 is bigger than 144. So triangle 1 is acute. Now we look here and I say, same thing, 8 squared plus 10 squared is something to 12 squared. This is going to be, no, sorry, we're on 13 now, 13 squared. It'll be 64 plus 100, and 13 times 13 should be 169. And so 164, that's a 7. What am I doing? 164 is less than 169, which makes this triangle, triangle 2, is obtuse. All right, 23. Is angle 4 a right angle if angle 3 and angle 4, angle 3 and angle 4, son of a gun, why is it writing like that? I don't know, who knows? Angle 3 and angle 4, if they are supplementary, does that guarantee that angle 4 is a 90-degree angle? No, it does not. Angle 5 and angle 8 are right angles. If angle 5 is 90 degrees, angle 4 is alternate interior angle to it. So yes, this does guarantee that they are right angles. Now angle 1 and angle 2, now I can erase all that. I can get rid of my 90s, right? I'm going to say this one was true, this one was yes. Sorry, this one was yes, this one was no. Erase everything I've got so I can start over. Now this next one, angle 2 and angle 4 are consecutive angles. Well, we know they're consecutive, but that doesn't guarantee that they're 90 degrees. Now 4 and 6 are interior angles. Well, we know they're interior angles. We can look at it and see that. That doesn't make them 90 degrees. So I put no. Okay, 4. Use the conversion factor below to determine the closest answer. How many fluid ounces per second are equivalent to, just writing all over the board here, are equivalent to 3,000 pints per hour. All right, so here's the conversion factor. I've got to practice my reducing fractions, don't I? I take 32 fluid ounces, divide that by 2. That's going to give me a 16 on top over, and that got rid of the 2. I reduced my fraction. Now I've got 16 fluid ounces over, that's not set up correctly though. See that? Something's going on here. There's 32 fluid ounces in a quart. Every quart has 1 pint. Every hour has 60 minutes, and every minute has, here's the piece, 3,000 pints per hour. So I come over here and I say 3,000 per hour. And this is going to be pints. I'm going to put a P right there. So the pints cross off with the pints. Quarts cross off with quarts. I'm left with fluid ounces on top. Okay? Hours cross off with hours. Minutes cross off with minutes. And I'm left with seconds on bottom. So my units are seconds and ounces. That's what I want. I want fluid ounces per second. So doing that leaves me with my numbers of 3,000 times 32 divided by 2 times 60 times 60. So now the 2 and the 32 can cross off and I'm left with 16 on top. So this leaves me with, on the bottom I'm going to have 3,600. On the top I'm going to have 3,000 times 16, which is the same thing as 6,000 times 8. 6,000 times 8 gets me 0, 0, 0 with a 48 at the end. So this is 48,000 divided by 3,600. Okay. Now, when I reduce the fractions, the zeros go away one at a time. So now I'm left with 480 divided by 36. Well, I can go by 2s, 4s, 8s maybe. No, it looks like we're going to go by 4s. So if I divide the top and bottom by 4, I get 9 on bottom, because 4 goes in there 9 times. And I get 120 on top. Now I know a 3 can go into both of these. So I divide by 3, and I end up with 3 on bottom and 40 on top. So my final answer is 40/3. Notice how I did times by 3,000 over hour to get the units to cross off correctly? Well, then it's just reducing fractions. 3,000 times 32, the 2's crossed off, times by 16, cross off my zeros. However you want to go about reducing your fractions is fine, but as long as you get down to 40/3 as your final answers. The main point. Which theorem can be used to find the missing side length of any right angle triangle? Which theorem can be used to find the missing side length? Well, we use the Pythagorean theorem. So the Pythagorean theorem is what the answer is right there, because we use it to find right angle triangles. What is the intersection of plane GIH? GIH, that looks like it's the front of this box. Okay? And IHJ looks like it's this left side of the box. The only places those two boxes touch is right there on that side. So the intersection is HI, or high. That's kind of cute. All right, 27. Which is the length of the sides of the right triangle are integers? Which one would you construct to be a counterexample? The sides have to be integers, and then the long part doesn't. I would go with D because it's isosceles. This is supposed to be x root 2, right? Because it's 45 and 45. There's some math there. Also, you could look at Pythagorean triples. 5, 12, 13. What is it? 7, 25, 7, 24, 25, something like that. And then there's more Pythagorean triples there. Can't remember what they are. I had them memorized when I was your age, but I don't anymore. D is the only right answer. 28. Use the figure below is made with a triangle and a parallelogram. What is the area of the entire figure? Wow, sweet. The parallelogram, formula for a parallelogram is 10 base times height, which is 10 times 6, which gets me 60. So the bottom part's area is 60 inches squared. This top part is going to have a half the base times the height, which is going to be 5 times 6, which is 30. So total is 60 plus 30, gets me 90 is my total. 29. Determine which the side of the stream. Okay, we're going to set up a proportion. We're going to say 50 over x is equal to 65 over 45. I'm going to reduce this fraction down by 5s, and I'm going to end up with 9 on bottom and 13 on top, looks like. Cross multiply, I get 13x equals 5 times 90 is 450. I divide by 13, divide by 13. X equals 450 13th. Sure hope I did that right. Looks good to me. 13's prime, so I can't reduce it at all, and we move on. That's how I'm going to check my answers on. 30. Shadow of a 12-foot pole. This is another proportions. We say, what is the height of the student? 12 over x is equal to 18 over 6. This reduces to be 3 over 1. Cross multiply gives me 3x equals 12. Divide by 3, x equals 4. So the height of the man is 4 feet. Back over here on the right side.